In the last video, we talked about the product rule. Now let's talk about what happens if you have a quotient that you are doing. In other words, you're dividing two things. So typically this means what we're talking about here is when you have a function over a function, not just like 3 over x squared or things like that. While doing the derivative of y equals 3 over x squared, you could certainly use the quotient rule to do this, but we have learned that it was easier to turn it into a negative exponent. What we need to be aware of is that we are not doing that with quotients like this. It is a function over a function with pluses and minuses in it, so we need to use the quotient rule. Now the quotient rule, again, it's an easy formula to use because you're just taking derivatives like you normally do, but sometimes it's not the easiest thing to remember. So we're always going to assume that our f is going to be on the top and our g is going to be on the bottom. Now it's very important that we go in this order right here. So maybe, even though the video may have been a little bit different for the product rule, maybe it's good for you to always start with this portion on both the product and the quotient rule. In other words, start with your f prime, that's the derivative of the top, and then g of x. So in other words, what we're going to do in this is it's going to be the derivative of the top times whatever's on the bottom minus whatever's on top times the derivative on the bottom all over what was originally on the bottom squared. So f is going to be the top, g is going to be the bottom. F prime is going to be 3 minus 4x, and g prime is going to be equal to 4. So we're going to do this exactly as it's recommended with the formula. It's going to be the derivative of the top, so 3 minus 4x times the bottom, which is 5 plus 4x, minus, notice the quotient rule is a minus, not a plus, and then it's going to be the derivative of the bottom, which is 4, times what's on the top, which is 3x minus 2x squared, and then all of that will be over the bottom squared. Now, one thing I want to point out, you do not need to do anything with the bottom here. This is fine. You do not need to FOIL this out. You don't need to do any of that. All you have to do is multiply the top out and simplify that. So this will be 15 plus 12x minus 20x minus 16x squared. And then we have minus 12x, and negative 4 and negative 2 is a positive 8x squared. Don't forget that when you're multiplying, it's negative 4 times 3 and negative 4 times negative 2 there. So then, again, that's still over this. We don't need to change the bottom at all. That's 5 plus 4x squared. And then we simplify the top. So we have negative 16 and positive 8 will be a negative 8x squared. 12, the positive 12x and the negative 12x will cancel out, so we have minus 20x plus 15, and all of that will be over 5 plus 4x squared. And as we've been saying all along, it's really not the calculus that's going to get you here. It's going to be just your basic algebra skills and making mistakes there. Other than that, it's just a simple formula that you are going to be using over and over again with quotients. So let's look at another example with trig functions. So again, our top is always our f, our bottom is our g. So our f prime here, the derivative of 2x is just 2. The derivative of our bottom g prime is just going to be cosine of x. So let's go ahead and do this. The derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, so I'm going to simplify the top to be 2 sine of x minus 2x cosine of x. And notice how I always put the trig function at the end. Now, here's one thing that you need to learn, and you need to understand the notation of this. Sine x squared, the reason why I'm going to write it a different way, and you need to be familiar with how this looks. So this is sine, this is the same thing. These two are the exact same thing. The reason why we put the squared after the sine is we want you to realize that it's the sine of x that's squared, and it's not sine the mistake that most people make is they write sine of x squared, and that's not right, because that, in this case, only the x would be squared, not the entire sine function. So make sure that you understand that a squared on the outside of a trig function is the same thing as putting it right after the trig symbol. So, okay, so there's one here for you to try on your own. Again, try this, see if you can do it. Hit play when you're ready so you can see if you have the right answer. Okay, so for this one, again, we label the top as f, the bottom as g. Take the derivative of each one and then apply our formula. F prime times g minus g prime times f all over g squared. And again, you could have multiplied this through. The one thing you want to make sure, you will not get full credit if you forget this x. Okay, remember, this is not the cosine of 6x minus 2. This is the cosine of x times 6x minus 2. This is the sine of x times 3x squared minus 2x. So just don't forget your x there. You still have the cosine or the sine of x accordingly. And then, of course, on the bottom, we have our g squared, which is cosine squared of x. So hopefully that makes sense. We're going to move on to the back page here. So this is one last thing that I want to talk about. There's not any examples, but I just want to kind of talk about this real quick. The derivatives of our other trig functions. So the reason why we wait for this is because the tangent, again, this is something that you guys can just learn and you can remember. I know that it's not the easiest thing in the world to remember them, but the more you use them, obviously, the easier it is. But just real briefly, I want to talk about how we get the derivative of tangent of x being secant squared of x. And it's pretty much how you would find all of these. So tangent of x equals secant squared of x because, if you recall, tangent of x is equal to the sine of x over cosine of x. So what we can do is we can actually do the quotient rule here, where the top is f, the bottom is g. F prime is equal to cosine of x. G prime is equal to negative sine of x. And then we do our quotient rule. So it will be cosine of x times cosine of x minus, and then we do our g prime, which is negative sine of x, times our f, which is sine of x. So we end up with, on the top, cosine squared of x plus sine squared of x, and on the bottom we square our g, which is cosine squared of x. What this equals is, if you recall from trig, which many of you may not, cosine squared of x plus sine squared of x is just equal to 1. And then we still have our cosine squared of x on the bottom. And if you recall, 1 over cosine is secant. So this is equal to secant squared of x. That's how the derivative of tangent is derived, but you can just remember that's what it is. It's just, if you ever get into a pinch, maybe you can remember, as long as you understand that tangent is sine over cosine. If you didn't remember what the derivative was, you could figure it out using the quotient rule. So again, hopefully this makes sense. Take your Edmodo quiz if that's been assigned, and I will see you in class.